All right, we are moving on to 7.2 today, properties of rational exponents, and we're going to have only variable bases today. We are going to take all of the rules that we reviewed from 6.1 with our exponent rules. When do we multiply? When do we add those numbers? When do we subtract the exponents? And we're going to combine those with all of the rules that we learned about fractional exponents and radicals from yesterday. And we're going to combine those two together and write these in simplified form. When we write our answers in simplified form, we always want them to be in radical form. If you look at the answers in your book will always have the answers in fractional form. You must ignore the book. You have all of your homework answers typed up, so make sure you look at the typed up answers and not the book answers. So we look at our first problem. We've got the cube root of 2x squared and the cube root of 4x to the 7th. We are multiplying these two pieces. We want to look for something that they share, something that they have alike that we can make them combine together. In this case, they have the same root. If they have the same square root and we are multiplying them, we can just multiply them under the same square root because they're the exact same root. So that gives us the cube root of 8x to the 9th power. Now we have to simplify it. We have 8, which we know is 2 to the 3rd power. We need groups of 3 to move to the outside. We have a group of 3 2's, x to the 9th. If I need groups of 3, I have exactly 3 groups because 3 times 3 gives us 9. Nothing is left over, which means there's no radical left. We look at number 2. We see that they have the same base. If our bases are the same and we are multiplying them, this is where we go back to our 6.1. Multiplying the same base, you add the exponent. So this is x raised to the 2/3 plus 1/6. If you're not good with fractions, some people are, that aren't, that's fine. Just make sure that you're entering it into your calculator correctly and that you can add the fractions in your calculator correctly. One way or the other, you gotta add them correctly. 2/3 plus 1/6 is 5/6. This is what your book would have as an answer. That's not good. We need to change this into simplified radical form. X is the base, 5 stays with the x, the denominator is your root. We need groups of 6 to go to the outside, and we have only 5 x's. So we're done. That's our answer. Number 3. We have x to the 3/2 raised to the 6/5 raised to the 10th. We have a power raised to a power raised to a power. And our rule of a power to a power means we multiply. So we are multiplying 3/2 times 6/5 times 10. And again, if you're not good with fractions, just make sure that you're entering it into your calculator correctly. You want parentheses around your fraction so those parentheses, or so those fractions stay together. 3/2 times 6/5 times 10 is going to give you x to the 18th. Sometimes it works out nicely like that, sometimes it doesn't. But in this case, we don't have any fractional exponents left, so we're done. We're good. Number 4, what I would do for number 4, and this is why in the first video I said make sure you're comfortable going in between from radical form to fractional form, from fractional form to radical form. Sometimes it's easier to deal with things in radicals, like number 1, we had everything we needed, we didn't have to change to fractional form. But in number 4, even though I want my answer as a radical, I prefer to take this and change it into fractional form, simplify, and then go back to radical form. So you've got to really manipulate back and forth between your forms. X is my base, and I've got it raised to the 3rd power to the 4th root. So that first radical inside is x raised to the 3/4. Well, that whole thing is being raised to the 6th root, which means the 6th root is 1/6. So if I go from radical form to fractional exponent form, I see that I just have a power to a power, and I take 3/4 times 1/6, and I get x to the 1/8. You get 3/24, which reduces down to 1/8. Now that I have my answer simplified, I need to go back into radical form. X is the base, raised to the first power, taking the 8th root. Number 5, again, we look, and what I see immediately is the fact that I have the same root. If I have the same root, I can put them underneath one square root. So it gives me x to the 19th over x to the 4th. We pull from those 6, 1 properties. If I'm dividing bases, I'm going to subtract those exponents. So 19 minus 4 is going to give us the 5th root of x to the 15th. Now we've got to see if we can simplify that. We need groups of 5 to go to the outside, and I have 15 x's. That means I can pull out exactly 3 groups of 5. When we go to number 6, I don't have same roots, but I do have same bases. I've got x's and I've got y's. So we're going to handle those individually. I have x to the 5/3, and this is, remember, x to the first power. If I am dividing bases, I'm going to subtract exponents. So I look to see who wins. Don't forget about our who wins rule. We have 5/3 and we have 1. 5/3 is bigger than 1, so the top is going to win. So we have 5/3 minus 1, which is going to leave us with 2/3. When we look at our y's, we have that negative exponent. To get rid of the negative exponent, we have to do the reciprocal, and we have to move it to the top. So that's y to the positive 1/2. So that's 1 plus 1/2, which is going to give us 3/2. So now we have, it's simplified, but it needs to go into simplified radical form. These are going to go into 2 different radicals. This is the cube root of x squared. Remember, the squared is with the x, so that stays inside the cube root, times, this is the square root of y to the 3rd. You don't have to write that 2, it's assumed to be there. We look to see if we can break it down. We need 3, we only have 2. With our y's, we need 2, we have 3. So I have enough to bring a y out. So I've got the cube root of x squared times y, square root of y. Again, I only needed 2, I had 3. I could bring one group to the outside with 1 left over. With number 7, couple different ways you could do this. You could distribute first, or you can combine first. I see that I have the 4th root. When I see that common root, my first instinct is to combine those together, which means I'm going to multiply on the inside. So that's really going to give me, if I'm multiplying bases, I am adding the exponents and that quantity squared. What I would do, again, sometimes it's not as easy to deal with it in radical form. I'm going to change that into a fractional exponent. And we know that 8 divided by 4, well, that's just 2. So that's x squared, all squared. And it simplifies really nicely to just x to the 4th power. Or what you could have done is you could have changed to fractions right away. This is x to the 5/4 times x to the 3/4, all being squared. We're multiplying same basis, so we add their exponents. 5/4 plus 3/4 is 8/4, which again gives us the exact same answer. So you have to kind of feel out which way is more comfortable for you. What do you like doing? And if you approach it down one path and you get stuck, that's fine. Just try another avenue, try another route. What can you do instead of what you did? Go back to the beginning and start over, which isn't always fun, but it's better to start over and get the right answer than get a 0. And number 8, we've got the 3rd root, and we're lucky. All 3 pieces have the cube root. So I'm going to put these all under one radical, and I can see what is going to cancel out. Alright, so we've got x cubed on top. We're multiplying bases on the bottom, so that's going to give me x to the 9th. We're dividing like bases. They're both a base of x. I play the who wins. 9 is bigger. So this is the cube root of 1 over 9 minus 3 is x to the 6th. The cube root of 1 is just 1. The 10th root of 1. Just like 1 raised to any power is just 1, any root of 1 is just 1. And the cube root of x to the 6th power, we need groups of 3. We have 6, which means this is going to be x squared. All right, turn on over to the back page. You will and you can see problems with irrational exponents. So if they're irrational exponents, those are numbers that can't be written as a fraction. So like the square root of 3, as you see in number 1. If you went to your calculator and you wrote the square root of 3, it's all these crazy decimals that are never going to equal anything written as a fraction. So we are multiplying like bases, which means we are going to add those exponents. It's not pretty, but it can be done, and that's your answer. 2 and root 3, those aren't like terms, so you can't add them together. You're done. Here we've got a group raised to a power. We just multiply it in. It doesn't matter what you're multiplying in. In this case, we're multiplying in a pi. You still distribute it just like you would if it was a 2. So don't get freaked out just because you have different pieces. Here we have the same base, which means we're going to subtract those exponents, which means this is x raised to the 4 root 2 minus root 2. Well, if I have 4 root 2's and I take away 1 root 2, that's going to give me x to the 3 square root 2. Okay. In a previous video, I said when we had a radical on the bottom, don't worry, we're going to come back to that. Now is that time. We have to rationalize that denominator. We can't have square roots on the bottom. So we have 5 over the cube root of x. That root tells me that I need groups of 3 to go to the outside. Right now, I only have 1 on the inside, which means I'm missing 2 more in order to create that perfect cube root. So I'm going to multiply the top and bottom by the cube root of x squared. The reason we do that is now on top we've got 5 times the cube root of x squared. On the bottom we have multiplying bases, which is going to give us x cubed. If we have the cube root of x cubed, I now have created that perfect cube root. To get rid of the cube root, we have exactly 1 group of x's that can go to the outside. We can't simplify those pieces. Remember, with radicals, it's all about location, location, location. Inside numbers stay together, outside numbers stay together. This x and this x are in different locations, so that would be my answer. All right, let's move on to our next one. We have the cube root of x's and y's. When we have different bases and we can't simplify, I break it down into the numerator and the denominator. So I have the cube root of x to the 6th power. I need 3, I have 6. That means I can pull out exactly 2 groups. Here I have 3 and I need 2, which means I need to now rationalize. I need 3, I have 2, I need 1 more. So I'm going to multiply top and bottom by that 1 more that I needed. So on top I've got x squared times the cube root of y. On the bottom, 2 plus 1, I now have that group of 3 that I needed. So it moves outside of the radical. So I've got x squared times cube root of y on top, all over y. Again, no radicals are allowed in that bottom. So you have to create that perfect square root, that perfect cube root, that perfect 4th root to get rid of that radical. Number 3, don't forget that if there's no number there, it is that assumed square root. And that brings us back to everything that we've learned in previous years. I have x, y, z, a, b, no like variables to break down. So I'm going to break it down into the numerator and the denominator. And let's see what we can take to the outside. We need 2 for our a's. We have 6. So 6 divided by 2, that gives us 3 groups for our a's. 9 divided by 2, that gives us 4.5 groups. Oops, that's a y. And that's an x. What was I thinking? Sorry about that. So let's correct all of my little mistakes there. We have 9. We need groups of 2. We can create 4 groups of 2, but now there's one y left over on the inside. Z to the 4th, groups of 2, we can create exactly 2 groups of 2. On the bottom, we've got 3a's. We can pull out one group of 2. That leaves us with 1 left over. B to the 4th, we can make exactly 2 groups with none left over. So now we have the square root of a left on the bottom. We need 2, we have 1, so we need 1 more. So we multiply top and bottom by the square root of a. That leaves us x cubed, y to the 4th, z squared. These are the same root. Therefore, I can put them together under 1. Now, if this was a cube root and that was a square root, you would leave them as 2 separate radicals. So make sure that you're only combining them if they are like radicals. On the bottom, we had a times a. That gives me 1 more group that can move to the outside. So even though I already had 1 there, I'm bringing a second one out. So that becomes a squared, b squared. Alright, last topic for today is adding and subtracting variable expressions. Anytime we are adding subtracting with variables, we have to have like variables. Same is going to be true for radicals. If we're going to add radicals together, they must be like radicals. And this is what makes them like radicals. Same radical, same piece on the inside. So I have 2 of these plus 7 of those. So now I have 9 of them. The radical is not changing, just the how many. When we look at number 2, they're not the same. But we do know how to simplify. If they're not the same, then yes, you can add and subtract them. But you do want to make sure that your answers are always in simplified form. We are taking the square root. The square root of 4 is 2. We've got 5 of them, which means we can bring 2 groups to the outside. And that leaves us with 1 x left over on the inside. Minus, we already have an x out there. We need 2, we have 3, we can bring 1 group out, leaving us with 1 x on the inside. So that's 2x squared, square root of x, minus x times x is x squared, square root of x. These are like radicals because they're both square roots of x's, which means we are adding their coefficients together. So in this case, subtracting. If I have 2x squareds and I take 1 away, I have 1x squared left times the square root of x. Only the how many is changing, your radical is not. And our very last one, we have that quantity squared plus that quantity to the 1/4. Go ahead and distribute that in. 2 squared gives us 4. 4 times 2 is x to the 8th. 1/2 times 2 is just 1. Plus 3 times 1/4 times 32. So you're multiplying those, which is really 32 divided by 4. Gives you x to the 8th. 4 times 1/4 is 1. Again, when we are adding and subtracting, in this case we are looking at the variables. Same variable, same exponent. 4 plus 3 gives us 7 x to the 8th y. Alright, I know this is a lot. Just try to make sure that you are really staying on top in this chapter, and when necessary, always re-watch those videos. There's lots of rules, lots of things to double check for. Alright, we are all done for today.